Hello everyone, welcome to the video. So our today's question is, if the angular momentum of a planet of mass m moving around the sun in a circular orbit is L, about the center of the sun, its aerial velocity is. So in this question we have to find the aerial velocity of the planet, that is the mass is given m, and around the sun in a circular orbit of angular momentum L. So first of all, to see the solution, we should know the basic formulas, that is for aerial velocity. Aerial velocity, we have the formula as area upon time, area upon time, where time is given as time period of a circular motion is given as 2 pi r upon v, that is velocity, and area is given as pi r square. Let us suppose the orbit is circular. So let us give its denotation as A, capital A, to the aerial velocity. So we can write capital A is equals to area, we have pi r square, and time period we have 2 pi r into v. So after cancelling pi by pi and r from r, we have A equals to small rv upon 2. That's our first equation. Now let's see for angular momentum. We have angular momentum. The formula for angular momentum is given as L equals to mvr. mvr. So putting the value, getting the value of v, we have L upon mr, and this is the second equation. Putting the value of v in equation first, so we get capital A, that is aerial velocity, is given as L upon m r into r by 2, that is this. So cancelling r by r, we get aerial velocity A as L upon 2m. That's the answer for the question.
हेलो स्टूडेंट, इस क्वेश्चन में कह रहा है कि बाइनरी स्टार कौन सिस्टम है, ठीक है। ए और बी, स्टार ए है स्टार बी है, जिसका कह रहा है कि स्टार ए का मास एम ए है, टाइम पीरियड टी है और रेडियस जो है आर ए है, और स्टार बी का टाइम मास जो है एम बी है और रेडियस आर बी है और टाइम पीरियड टी बी है। तो इनमें से कौन सा जो है ऑप्शन करेक्ट है वो हमें फाइंड करना है, ठीक है। तो हमें टाइम पीरियड के संदर्भ में बताना है कि कौन सा ऑप्शन करेक्ट है, क्योंकि सारे ऑप्शन में टाइम पीरियड का कुछ ना कुछ है, ठीक है, रिलेशन है। तो हम चलिए टाइम पीरियड से, अगर मान लेते हैं कि ये स्टार जो है ना रिवॉल्व कर रहा होगा कि कुछ इस पाथ पे, ठीक है, और दूसरा स्टार जो होगा रिवॉल्व कर रहा होगा कुछ इस पाथ पे, ठीक है। अगर मान लीजिए कि एक जो है स्टार यहाँ पे है और एक स्टार यहाँ पे, तो दोनों में फोर्स कितना लगेगा? दोनों में फोर्स जो है सेम लगेगा, क्योंकि ग्रेविटेशनल फोर्स कारण ही जो ये घूम रहा है सेंट्रीपिटल फोर्स के कारण, ठीक है, वो ग्रेविटेशनल फोर्स प्रोवाइड करेगा। सो फोर्स जो है ना दोनों के ऊपर सेम लगेगा, क्योंकि इसके ऊपर इधर फोर्स लगेगा, इसके ऊपर इधर फोर्स लगेगा, ठीक है। अगर मान लेते हैं कि डिस्टेंस डी है दोनों के बीच में, तो फोर्स जो होगा सेम होगा। अगर यहाँ पे फोर्स अगर सेम है तो यहाँ पे ओमेगा जो है जिस ओमेगा से घूम रहा है, क्योंकि वो सेंट्रीपिटल फोर्स के कारण घूम रहा होगा, ठीक है, एम ओमेगा स्क्वायर इंटू आर से, ठीक है, ये फोर्स इज इक्वल टू, क्योंकि यही फोर्स जो है सेंट्रीपिटल फोर्स प्रोवाइड करेगा। अगर मान लेते हैं कि m1 है इसका मास, ठीक है, और इसका एम ए दिया हुआ बाय द वे, ठीक है, ये स्टार ए है और ये स्टार बी है और एम बी है, तो ग्रेविटेशनल फोर्स कितना लगेगा? जी एम ए एम बी अपॉन दोनों के बीच का जो भी डिस्टेंस होगा डी स्क्वायर, ठीक है, ये एम ओमेगा स्क्वायर इंटू आर हो जाएगा। तो ओमेगा जो होगा दोनों का सेम होगा जिस ओमेगा से घूमेगा, क्योंकि दोनों पे फोर्स सेम है। यही तो फोर्स है जो कि इसको प्रोवाइड कर रही है सेंट्रीपिटल फोर्स, ठीक है। तो ओमेगा दोनों का सेम होगा। ओमेगा जब सेम होगा तो टाइम पीरियड और ओमेगा में क्या रिलेशन होता है? टाइम पीरियड इज इक्वल टू होता है 2 पाई अपॉन ओमेगा। अब ओमेगा सेम है तो टाइम पीरियड दोनों का सेम होगा, ठीक है। सो टाइम पीरियड ए इज इक्वल टू टाइम पीरियड बी इज द राइट आंसर। सो अगर हम ऑप्शन देखें तो डी में यही दिया हुआ है। सो डी इज द राइट आंसर।
Hello everyone. If the distance between the Earth and the Sun were half its present value, the number of days in a year would be. So now we know that the number of days in 1 year is 365. What will be the number of days in a year if the distance between the Earth and the Sun is reduced to half? So how the time period depends on the distance between the Sun and the Sun and the Earth. It is like this, right? So it is directly proportional to this. T is directly proportional to. So if the distance will decreases, then the time period will also decreases, right? So you can get this relationship by writing the centripetal force equation, right? Here the gravitational force, this will act as the centripetal force, and you know that this omega is equals to 2 pi by t, and you will get this relation, right? Now let us see what will happen if I reduce the distance between the Earth and the Sun by half. So as you we have seen that it is proportional to r to the power 3 by 2. So I will write t dash by t is equals to r dash to the power 3 by 2 by r to the power 3 by 2. So it is reduced by half. So I will write this. So this is under root of 8. So under root of 8 is 2.282, right? So I will write this is 365, 2.828. So it is 129 days. And this is the answer of this question. I can check for the option. So B here is the correct option. Thank you.
Hello, here's the question is, imagine a light planet revolving around a very massive star in a circular orbit of radius r with a period of revolution t. If the gravitational force of attraction between the planet and the star is proportional to r to the power of minus 5 by 2, then which of the following option will be correct? The options are in proportional with the relationship with t and r. So first of all, let me draw a circular orbit. So anything, suppose a massive planet which is located here. Okay, this is the orbit, and this a satellite. Suppose a satellite, we know a satellite is revolving round this planet. This satellite will experience a pull in the center of this orbit, towards the center of this orbit, because this planet is massive according to the satellite. So suppose this planet is M and this is M. So M is much greater than M. So it will get a pull. This M will get a pull. So this pull is nothing but the gravitational pull, and it maintains the satellite to revolve around this orbit. Similar way, here the light planet we can refer as the satellite, and the massive star we can refer as a planet. So now since the gravitational pull, this gravitational pull, let it be Fg, okay, which is proportional to r to the power of minus 5 by 2. And this gravitational force is and the centripetal force are interrelated, because this is a circle. Anything, the force which is experienced inside it is a centripetal force. So that centripetal force is mv squared by r. But here the centripetal force is due to the gravitational force. So Fc will be equals to Fg, right? Now since Fc is equals to Fg, therefore Fc is also proportional to r to the power of minus 5 by 2. Okay. So here if I substitute this v square by r, that equation relation of Fc, mass is constant. mass of anything is constant. So this one I can write like this way, proportional to r to the power of minus 5 by 2. Again, we can write v square is proportional to r to the power of minus 5 by 2 plus 1, which is proportional to r to the power of minus 3 by 2. Therefore, v is proportional to r to the power of minus 3 by 4. So this a relationship we got with v and velocity and radius of the orbit, right? Now, the time period of revolution. Time period can be expressed as circular orbit. So circumference by time by velocity is a time period. So we can write time period as 2 pi r by v. Now time period is proportional to 2 pi is constant, r by v, and v is proportional to r to the power of minus 3 by 4. So time period will be proportional to r by r to the power of minus 3 by 4. So now we solve this one. Again it will be proportional to 1 plus 3 by 4. So therefore t is proportional to r to the power of 7 by 4. Now in the option, get back to the question. Everywhere all the options are t square. So now this, let us convert this t to t square. So t square is proportional to r to the power of 7 by 2. Now let us see which option matches our answer. The option B, it matches our answer. So B option is the correct option. I hope you like my video. Thank you.
Hello dear students, here the question is, according to Kepler's second law, the radius vector to a planet from the sun swept out equal area in equal interval of time. This is the consequence of conservation of. We know that the radius vector drawn from the sun to any planet swept out equal area in equal interval of time, that is aerial velocity of a planet revolving around the sun always remains constant. Here dA upon dt is aerial velocity of planet revolving around the sun, and it is always constant. But the value of this aerial velocity of the planet revolving around the planet is numerically equal to L upon twice m, where L is angular momentum and m is mass of the planet. It means angular momentum of the planet about the center of the sun is always constant. Thus we can say that this law is a consequence of law of conservation of angular momentum. This law comes from law of conservation of angular momentum. I hope this has cleared your doubt. Thanks for asking and keep asking. Thank you.
Hello everyone, let's start the question. Question says that a positive charge is released from rest at a distance r0 from a positive line. Charge with uniform density. the speed v of the point charge as a function of instantaneous distance r from line charge is proportional to. So here we have to find out the point charge, the speed of point charge as a function of instantaneous distance r from the line charge. Okay, so here we have to use energy conservation. We have to use energy conservation because this equation can relate the velocity to the voltage. Okay, we can write capital V. Here velocity is small v and voltage is capital V. Okay, so I can write Vf minus Vi, or we can write Q equal to del V. Fine. Now we have to find the voltage. Okay, change in voltage. So how can we find? So there is a relation between del V and the electric field. So we can write del V equal to integration r to r naught for this case. Okay, for this case, so we can write E dot dr. Okay, so if we integrate, we can find if we try to integrate electric field through this distance, this will be the change in voltage. Okay, also we know that the electric field E equal to lambda 2 pi epsilon naught. Okay, so into r. Okay, so if we write here minus r to r naught, the value of E is lambda by 2 pi epsilon naught by r into r unit vector whole multiply by dr. Now if we integrate this, here 2 pi epsilon naught and lambda is constant, so it will be outside of the bracket 2 pi epsilon naught, and we have to integrate from r to r naught. Okay, now we can write 1 by r into dr. So if we integrate this one will be 2 pi epsilon naught, and 1 by r, if we integrate 1 by r, it will be ln r, and the integration r to r naught, that is r to r naught. We can write minus lambda by 2 pi epsilon naught ln r naught by r. Okay, so now we want to remove this sign. So if we remove the signs, the r naught and r will be exchanged, and it will be, now we are removing minus sign, so it will be lambda 2 pi epsilon naught ln r by r naught. Okay, now we can substitute this value to, now can we substitute this value in place of del V. Okay, so if we rewrite the equation, half mv square, that is small v velocity, equal to q into del V, it will be q, and instead of del V it will be lambda by 2 pi epsilon naught ln r by r naught. So we can write here lambda by 2 pi epsilon naught ln r by r naught. Okay, so now we have to find relation between velocity and this quantity. Okay, so for velocity, what we can write? We can write velocity is directly proportional to, if we remove the square, it will be root under ln r by r naught. So the velocity small v is directly proportional to root under ln r by r naught. So if we see the options, v directly proportional to root under ln r by r naught. This is the correct answer. So we can write correct answer is root under b directly proportional to root under ln r by r naught. Thank you.